start, and then we'll go ahead and close that. All right, everyone. Hello and welcome back to Handmade Hero. We have been on break for a week, but it is now time to get back to coding a complete game from scratch, live here on Twitch. And we stopped before break at a point that was kind of somewhat interesting, actually. We were starting to do the work that we needed to do to make sure that we handled three-dimensional stuff correctly in our engine all the time. So we're a 2D game, meaning we're supposed to be a game that's similar to Binding of Isaac or Legend of Zelda, these sorts of games where you kind of walk around and it's very much supposed to be a 2D experience, or something I guess like Don't Starve. But we actually are trying to allow sort of full 3D stuff in the world in so much as we care to have it. So we want to make sure that there's nothing inherent in the way that we've made the engine work that would cause sort of jankiness to happen when you want to actually do stuff like multiple levels on top of each other or things like that. And we'd also like to be able to do stuff like have multi-level rooms where you can see perhaps the room below where you're standing in the case where there's a hole sort of in the floor down to where that is, that sort of stuff. So we want to make sure all that stuff is handled cleanly and not really in a hacky way. A lot of times there's kind of hacky ways to do it where there's exactly two levels that there can be or something like this, and or it's kind of just a hack in the way that the graphics are drawn, but it's not really handling it 3D. We're trying to do it a little bit more robust than that so we can do more interesting stuff if we so choose. Anyway, that's what we're working on right now, so I'm going to go ahead and get back into it because I think we're going to need some time today to just kind of get warmed up again. It's been a full week since we last programmed. It's been more, actually, because it's been 2 weekends in between, so it's been more like 9 days or something since we programmed. So what I'd like to do is jump right back into it. Again, if you already pre-ordered the game on handmadehero.org, you can download the source code. So if you want to follow along with today's stream is stream 76. At least I think I set that correctly. Let's double check and make sure that I haven't lost count. Yeah, 75. Was the last one. So what you want to do is you want to unpack day 75's source code from the source code zip file that comes with the pre-order. You want to unzip day 75 so that you'll be at the right place today if you're trying to follow along with me at home, because I will be starting with day 75's source code for this episode. All right, we can kind of put mischief down minimize that into the background for a second here. And I've restarted this computer since then, so hopefully everything is still working properly. I guess I don't know that it is. I guess let's just open up our programs and actually make sure that nothing has gone terribly wrong since we have left things. You never know. You restart Windows and anything can happen, ladies and gentlemen. You really don't know what you're going to get when you restart a Windows machine. Really, anything's possible. So it looks like things are roughly the same as when we left them. That's a good sign. And our stairwell looks like it's working as well, so that's good. So it looks like nothing particularly bad happened. We're still able to run okay. Everything looks good. And so if I remember correctly, what we wanted to do, what we had been planning to do at the end of this, was first of all, we wanted to maybe do a little bit of cleanup on how we were doing our collision detection for the stairwell, just kind of clean up some stuff. We had only just finished getting it working kind of the way that we had wanted it to work. And the other thing that we'd wanted to do is get our collision detection properly working with heights of things so that if entities are brought into the simulation set, like in this case, we've got sort of two playfields going here. We've got like a lower one and a higher one. You can kind of see these two rings of trees. That's sort of the downstairs, and this is the upstairs one that we kind of had put in there. If you've got situations where you've got multiple entities in the working set like this, and some of them are below you, right now we're just doing that collision detection in 2D, and that's not going to work because it means that we can't ever get through what should be an opening here, because we're going to collide with the trees on the bottom level as if they were trees that we would have to worry about on the top level. And so we need to make sure that we're actually taking into account where things are in 3 dimensions when we process collisions with them. So that's something that currently we do for inclusion testing. For example, when you're working with the stairwell, we are actually testing where you are in 3 dimensions there. But when we're testing against movement, like to see whether you can pass through something, to see if you've collided with something in that movement step, we're not actually using the height of things at all there to see whether or not you should collide. So that's, another thing we got to do. Finally, the big feature that we need to work on, and that's hacked in there in a minute, at the moment, and that we'll have to sort of do possibly at the end of this stream, and probably tomorrow will be most of what we do, is we need to start coming up with a definition for what it means to have a particular ground height. Right now, we're sort of just doing a really cheesy thing where we just assume that the ground height is wherever the camera is. So when the camera moves up and down, we set the ground height to be wherever its, sort of camera center point is. And that's not really going to necessarily work. I suppose we could decide to do something like that as the permanent solution, but it seems to me like, kind of a little janky, and it would also fight our ability to move the camera independently of where the ground is. It also makes it harder for us to define things that say where there isn't ground or stuff like this. I don't know. There's just, I haven't thought it through too much, and we need to go think it through so we can kind of define exactly how all that stuff's going to work, so we can get a nice stable way of understanding where the ground is. So right now, that's totally hacked, if I remember correctly. So that's what we've got, and that's pretty much we've got our work cut out for us there to get all that stuff going. So let's go ahead and start working on that. The first thing I think I'm going to tackle, because it's the easiest one to do, it's very straightforward, is just to get our collision detection working so that things are only colliding with you if they're in the same sort of Z neighborhood as you are. So if something's above or below you, that it won't collide. So what I'd like to do is I'd like to go ahead and go in here to our Handmade sim region, and when we do our move entity call, right, this is where that was happening. When we did our move entity call, we had this iteration loop where we would go through and we would try to move the entity, and we would do a check against other entities to see whether any of them were hit, right? And since we haven't really done general collision detection yet, we only did it just for little square things. We still have this, the call is still called test wall. And basically all it does is it just tests against a single basically line segment that is, on one of the axes, like X or Y or something like that, right? And if you'll notice, Z is not taken into account there at all, right? There's absolutely no Z included here whatsoever. And now what we could do is go expand the test wall function to actually handle Z, but it's unclear why, that's not really probably a good idea, because when we do the final collision detector, we're not going to use test wall, and the things are not going to be rectilinear, and they're not going to be axis aligned, and so really there's no point in updating the test wall call. The test wall call is probably fine for our purposes. What we'd rather do is just say, at the outset maybe, let's just say, we're going to look to see whether these two entities overlap in Z, and if they don't overlap in Z, we're not going to do any testing on them. So basically, we'll just in here, right, when we're actually doing this, we'll just full on say, when we look at the can collide, the first thing that we do after we do the testing, maybe we'll still leave that Minkowski diameter and the min-max corner thing in there, but right after we do that, we'll do some check to see whether the entities overlap in Z, and if they don't overlap in Z, then we simply aren't going to test them at all. Now, we've already constructed stuff that will help us test whether things are in Z. We've got this Minkowski diameter here, and the Minkowski diameter is the size of the entities added together. So basically, we've got the size of the entity in Z. We've got both of those sort of concatenated together, which means that we also we then use that to compute the min and max corner, which is basically the value of, excuse me, if you assumed that the entity itself that we're testing against, the colliding entity, if you will. I'm saying too many things here. I should probably just draw this out. That's probably the easiest way to explain what's already going on in the code, rather than me constantly trying to say stuff there. So let's go ahead and, thank you Windows for that wonderful, helpful, there we go. What I want to do is I'm gonna go ahead and find a place here where we can make a new thing. There we go. So we'll say day 76. And what I was trying to say before is we have two entities, right? Before we had basically the wall entity, or the entity we're testing against, which doesn't necessarily have to be a wall, but that's the most of the things that impede our progress at the moment. And we had the hero, right? And each of these had a dimension. So it had a measurement that said how wide or how high or anything it was, right? And so if you imagine we had the hero's dimension here and we had the wall's dimension here, so HD and WD, let's say, then what we decided to do, because if you remember the discussion of how Minkowski algebra works and stuff like that, what we wanted to do is just treat the hero as a point that moves along lines. And in order to do that, we need to shrink the hero down to a point and expand the things against which he is colliding against by his size, right? So what we did is we said, all right, let's expand the wall by however big the hero actually is. Half on this side, half on that side, right? Expand that out and treat the new size of the wall to be the size of the hero plus the wall, which effectively shrinks the hero down to a point for testing, right? And then we said, well, we'll do this relative to the wall, right? And so the way that we did that was we said, let's subtract that hero location, right? If this is the point that the hero is at, let's subtract that from wherever the wall is, and we'll just get a relative point. So what that means is now, if we wanted to do Z, if you imagine a side view here, what we've already done is we've already constructed something where we basically have the hero's point, right? We've got that relative to here, and then we've got a min and a max Z. Right? We've got a max Z level and a min Z level that already tell us sort of whether if we took PZ, right, it would just be this. It would just be where we are on the Z axis. We can just see whether that's in between that min or the and max, right? And that will tell us whether we can hit this entity or not. If we're outside of those bounds, then there's no way we're going to overlap with it, so we want to just ignore it at that point. So really all we have to do here, very straightforward, we can just take that rel. We can take that rel Z, and we can say if the relative Z is greater than or equal to whatever our min corner Z is, and the rel Z is less than or equal to whatever our max corner Z is. Now, and again, this is a little iffy here because we don't really have, you know, I'm gonna put a to do here when we finally do the full collision detection. Do we want an open inclusion at the max corner? Because you notice I'm doing less than or equal to in both cases. There may be, you know, if you remember when we did our rectangle code, and maybe I'll just do this because it seems like it's a little more consistent. But if you remember when we did it here, we were saying that the max typically is not included. So it may be a little more correct here to just say that for now. I don't know. We don't have a robust definition now. We don't know why we might care. And so I'm going to put that off till when we do the collision detection full pass, because at this point I really just don't know, if that makes sense. I really just don't know what it is that we would want to do there. We'll have to think about it. All right, so if I do that and I do that test, now we should have, and again, I'm not totally sure, but I believe we should pass through things that are not on our level and stop on ones that aren't. Okay, that looks like we're just passing through everything, which is not what we want to do at all. It's always funny. So I wonder why, I gotta see here what I'm doing oddly here. I'll set a breakpoint there and we'll see. But I believe, am I doing anything obviously stupid before I test that? If rel z is greater than or equal to min corner z and rel z, no, that looks basically right. So I'm going to step in there and see what's going on. Again, it's been a while since we programmed, so the chances of me forgetting something about how our code is working is pretty high, but what are you going to do? All right, so let's go ahead and step in here. We should, what's going on? There we go. We should be able to do some, oops, let's see here. I guess we should be able to step in at any time and we should be able to see these triggering, right? So let's see. What is our min corner and our max corner that we're testing against here? Let's just find out what those are. So let's see, min corner and max corner, they should straddle 0, right? And they should be roughly the size. What is this entity that we're testing against? It's a wall, so it should basically straddle either side of 0, and it does, which is good. And the z's in here, all right, well, so it looks like probably the problem that we're facing is just that we didn't actually give any height to our walls. So this is probably just a data definition problem because we didn't really add 3D to a lot of things. So when we add a wall, what we're going to have to do is actually add some depth to it. So if we go in here, we could say, all right, I don't know how high a wall is. You know, let's say that it's half the tile depth in meters or something like this. We'll have to think about that a little bit. There'll probably be walls of differing heights, I'm guessing, in the game when we're actually done with it, because there'll probably be walls that are low enough for flying things to fly over, and walls that are tall enough to block flying things, or, you know, stuff of this nature. And so for now, we kind of gotta, you know, leave it at that. So anyway, we gotta add that there, and then I suppose other things should also have a size as well. Probably the player should have a size. He currently does not appear to have a size, which is also odd. And the Monstars don't have a size, so most people don't have a size. Not sure what to really do about that. I guess we'll just give them some size for now. And I guess, so we've got a Y and an X. Yeah, I don't know. This is a little bit odd. 1.4F is probably what his height should be. I wonder if we should go through and actually think about these a little bit. Maybe that's something that should be on our to-do list. Feels like something that probably should be. So maybe go through and define how tall everything should be. And then, you know, just have some opinion about this. Because at the moment, we really don't know how tall things should be. And it's a little bit wonky. All right. And also for things that are flying, like the familiar, we should probably do a little bit of work on that. Make sure flying things can go over low walls. And so that'll be some good stuff to work out. All right, so we'll have to restart here because, of course, we changed the data definition. And so we'd have to, you know, the init code is where all that stuff was set. So let's see. We should find that we stop now, and we do. We do seem to stop correctly, although it seems like, are we stopping? Yeah, no, we're stopping correctly on the bottom stuff, which means I should not be able to go through the exit here because we're on the bottom right now. And now let's walk up to the top. We can walk up to the top, and we cannot walk through the top ring, but we should be able to go through. We can. So that looks like that's working properly now. So that's good. And yeah, that seems about right. Yeah, and I still can't walk through the familiar, which is good. I can't walk through the Monstar, that's also good. I'm not sure what's happening with this, but that's looking good too. So our collision detection is working stably enough at the moment for the 3D stuff. Wow, that's oddly jerky. I'm not sure why that's being odd like that. Is that, yeah. One thing that I did notice, you'll have to forgive me for a second here. I meant to check this out, but I totally forgot to. I meant to look to see when we did create window EX. Okay. I was noticing, I was programming some stuff earlier, like last week actually, and I noticed that if you pass WEX layered to a window, your frame rate gets really, really bad. At least in OpenGL. I don't know if it happens with div section like we're using here. So I just wanted to make sure that we weren't still passing that. It was just a quick thing that I had thought of, and I wanted to remember that not to do if we were doing it, but we aren't. It's not something I knew about, but it kind of makes sense, I guess, because if it's a layered window, it's got to go through the compositor first to do the layering stuff, and maybe, you know, can't flip as fast. I don't know. But anyway. All right, so that's, you know, that means our collision detection is good enough right now in Z, so we can kind of say that this is done for now. And then we can also go ahead and say let's take a look at the other two that we added here, I think, because that seems like that seems like something maybe we should go through and think about a little bit. And in fact, it kind of sets us up for doing the ground stuff as well, because in order to do the ground stuff properly, we should have an idea of how everything lines up in 3D and how things are stacked on top of each other, how that concept kind of works, where tile chunks are in terms of how things are staggered and all sorts of stuff like that. We probably want to get a handle on that. So yeah, so let's take a look and see what all this stuff hammers out to. So if I remember correctly, we set up a thing in here that said how big tiles were sort of height-wise. It's let's see, tile side in meters and tile depth in meters, this sort of thing. And what we said is that the tile side in meters is essentially what the depth, I guess I should say, of a tile. So if we imagine a tile as a thing, you know, sort of a unit that we think about typically as being this sort of element of space, we don't actually require things to be tiled at all, but it was sort of something we had been thinking about in terms of a unit of space. For example, if we were going to do walls that you stamp out, we'd probably do them in this proportion. So if we did something like this, what we're saying is that we've got a certain tile side in meters here, right? Whatever that is, whatever the world is initialized to. We're setting up the tile side in meters such that it's a cube, right? We're saying that these are all exactly the same. Like this, and this are all congruent. They're all the same length. And what's kind of weird about that is I don't think we actually care about height the same way that we do about sort of the two, or I guess we should say depth, as we do about the other two dimensions. Because if you think about it, when we're looking at the world top down, we typically want fairly fine gradations this way, right? In terms of entities. You know, we know that entities are moving around and we typically want pretty fine gradations there. But in terms of height, I don't know that we really do. Typically, we'll probably represent very tall things, you know, just sort of standing in a particular cell. And we don't really need the ability to have lots of things stacked on top of each other very often. That's not the common case for a game like this. It doesn't really happen hardly at all. And really, I don't know, it seems like we probably want to say that however high, you know, a floor would be of a building, that's really the size of the cell that we care about. So, you know, probably it's something that looks more like this, you know, where you've got kind of something that's very sort of tall compared to its footprint, that's actually the cell. And maybe that's, you know, a good 3 or 4 times however big that tile dimension would be, right? So if that's the tile dimension there. So that's kind of what I'm thinking. If you look at how high a building normally would be, a building floor might be like 10 feet high, let's say, right? You know, how tall is a typical building story? And let's see what this is. Calculating the height of a building, no, we just want to know how tall is a story, although 10 feet is a common estimate. So yeah, let's say 10 feet was a common estimate. What is 10 feet in meters? Well, it's 3.04, so close to 3. So we could say that 3 meters high would be probably a pretty good, you know, a pretty good estimate for how big we might want our cells to be in terms of how we chunk up the world, right? And so when we build this, I'm thinking that basically what we want to do is for tile chunks, we want to kind of do the opposite of what we did here in some sense, right? For a tile chunk, we're often only looking at one slice of the world. Well, you know what? The thing I was about to say is probably wrong. So I'm gonna stop there for a second. Let's think about this. So we have one more thing to think about. So if we're thinking about a typical element as something like this, when we start thinking about tile chunks, I think maybe what I was gonna say doesn't really apply. But let's talk it through for a second. So what a tile chunk is an aggregate, basically, and we don't call them tile chunks anymore, I guess we call them world chunks. It's basically a region of space where stuff lives, right? It's sort of a storage unit for stuff in the world, for entities in the world. And so if we're thinking about how big that should be, what we were saying before is, you know, maybe if this was what our common sort of construction element looked like, I think what we were saying is like maybe 16 by 16 across, right, was the thing? Yeah. So whatever that unit is of construction that we tend to think in, even though, again, we're not explicitly representing this anywhere, it's just kind of a size guide at this point because we allow entities to be any shape and positioned anywhere. So we don't have to, it's not like a tile map where it's locked to it. If we're saying that we're going to be 16 across, right, and 16 this way, the question is how tall should this chunk be in terms of units, right? So we're basically saying that this is, you know, something like this, right? This is, if this was our sort of construction grid, right? Wow, I did a bad job. This is not even square, the construction grid I drew. But you get the idea. Our construction grid basically says we store in chunks of this size in terms of construction elements. And again, things can be placed wherever you want in here, but this is sort of, you know, if you think of a typical wall piece that might be made by an artist that should be about that big or something, you know, blah, blah, blah. We're thinking about it in terms of stuff that would go like this in the world, right? So the question is, if that's what we're doing for how we're storing the world, 16 by 16, which seems pretty reasonable, but we haven't really thought too hard about it. How high should it be, right? And so if we're saying that, you know, there's 3 meters, so this is a distance of 3 meters here, right? If we're saying that there's 3 meters per floor, one question is, for tile chunks, how many floors do we want to store? And it seems to me like probably the answer. All right, so I'm going to go back to the thing I was originally going to say. Thinking it through a little bit, I'll say probably what I was going to say is okay. Anyway, but how many floors do we want to include in a chunk? And I think that probably we only really want to include 1 floor, right? Because typically speaking, there's not going to be a lot of visibility floor to floor. Like typically floors are going to be opaque. And when they're not opaque, they'll probably only show through to one thing below it or whatever, right? And so what I'm thinking is, in general, we probably don't want to be pulling in lots of entities that are not involved in the computation. We probably want to just pull in the floor that's active, and then if you can see down to the floor below it, we'll pull that in as well or something like that, right? But in general, we won't be pulling in lots of floors like that. And if it turns out that we don't ever allow this case, like we don't actually allow things that show through to the bottom, then we could restrict it just to the 1 floor. But I think we probably do, for visual interest, we'll probably want to do that once in a while. And so for looking down, what we'll have to do is basically do a query where we say, all right, let's look at everything that's inside the current camera bounds that we want to use, and then we'll expand that by when we detect that we have entities that would allow us to see through to the ground, we'll sort of detect that and add layers going downward. So we'll drill down or something like that, right? That's kind of the way that I'm thinking we'll probably want to do it. That way we've got some occlusion in there and we won't grab more layers than we need. And so what I think is we probably want to just leave it to 1 layer at a time in those tile chunks, so that we don't have a situation where we are constantly, excuse me, constantly pulling in all sorts of entities that we really just didn't need to simulate at a high frequency because they're not even visible at all, right? So that's what I think we should probably do for now. Now, in order to do that, what I want to do is say, okay, we'll leave all the same tiles per chunk stuff the way we were doing it before. And then instead of making this tile side in meters, we'll just pass in another thing here, which will be the tile depth in meters. Tile depth in meters. And you can see that I've already sort of done it this way. This is already sort of what I guess, for lack of a better term, what I was expecting when we first typed in this code. You'll notice that I had already just set it to 1 tile high instead of setting it to 16 tiles high when we were doing this before. But what we're saying now is we're going to do higher than that because really the tile side in meters is a lot smaller than what we expect the average floor depth to be. So we're going to set it to that, and then we'll store it in here as well. And so then when we call initialize world in here, when we actually, initialize world, we'll pass that tile side, and then we'll also pass whatever we want the depth to be, right? Which is going to be 3.0 for now, and that'll be that distance. Now, when we go to grab a floor, now we kind of have this thing where we got 2 competing things that sort of fight against each other a little bit, and I'm not sure how we want to handle it. Again, if you take a look at the side view, so let's do a side view here. If you take a look at a side view of what happens when we have a multi-story thing like this, right? Let's go ahead and do that. So let's say here's story 0 of our building and 1, 2, and 3, right? And you know, we've got a stairwell that kind of comes up in here, something like this. And you know, maybe we've got holes in here and a wall or something, you know, whatever, you know? So what we have to consider is, previously what I was saying is to avoid numerical nastiness where we kind of have things that are standing on the floor that might drop a little bit below the floor, or things like, you know, who knows. I was worried about that, and I was saying, well, we probably want to make it so that tiles are like straddling like this, that world chunks are straddling so that they capture everything that's near the floor boundary. But the thing that's nasty about that is that would bring in, right, in a tile chunk, you would easily potentially say that like things like this that were overlapping this might go into this chunk instead of going into this chunk, right, depending on where this was placed. A floating thing that was floating up here should clearly be in actually this tile chunk down here related to this floor, but instead it's going to be placed in this chunk. And our gather would find that, because our gather is going to gather everything, you know, in a region that looks like that. But what that means is we're always gathering 2 tile chunks, even if we could only see one floor, right? Even if this is all we could see, here's my little, that's my little eyeball. It's pretty great, huh? If this is all we could see is just this floor, you know, we can't see any of the rest of this. We're still pulling in all of these entities. We might still be pulling in entities up here, and that's just not a good idea. So it does seem like maybe, even though it's a, you know, kind of a nice thing to do it this way, it does seem that maybe we want to do is do a nice inclusion thing where we actually do, and this would be our max thing would come into play here, where we actually do something where we say, okay, let's actually make it so that a tile chunk actually just encompasses the floor itself, and it doesn't extend below or above the floor boundary. Now maybe we can stagger it a little bit. You know, maybe we can say that it's like a little bit like this, so you know, it has a little bit of give to it, so things are staggered a tiny bit. But on the whole, you know, maybe let's actually keep it fairly well aligned in that sense. And so if we want to do that, I guess let's see here, when we actually do our recanonicalized coordinates here, I'm not sure exactly what we're doing already in terms of how we recanonicalize them. Let's take a look. Actually, I guess it's not recanonicalized, it's chunk position from tile position, where we're actually placing these guys. And so offset, let's see what we're doing. We're saying the world tile side in meters times the abs tile in any direction. So this is kind of a little bit wrong now, because again, tile side in meters is not how deep things are going to be. And so we really don't actually want that to be the case for these guys. What we actually want to do here is take just the x and y and multiply it by it. But you know what I could do? We could just say this is the you know, tile dimension or something like this, where we go ahead and say, okay, it's the tile side in meters, and then it's the tile depth in meters, and then this is just a Hadamard product, right? Hadamard product of our tile dimension times that abs tile xyz. That'll give us what we actually wanted for the position, right? And that should work good. But now we got to say, all right, so how are these things being sort of placed? And it may be that we're already placing them in the way that I just said that we should. It looks to me like nobody here is doing an offset, which means, correct me if I'm wrong, but that would seem to suggest that we're actually already doing exactly what I just said, right? In other words, we don't have to do any work. That was just what was happening already, and it's only if we wanted to do the staggered version that we would have had to actually do something about it. Because if we set the abs tile z to 0, then obviously we would end up with 0. If we set it to 1, we would end up with it being 1 more over. And so really, if anything, I would say that all we really have to do here is we'd want to do an offset we'd want to do an offset for the X and Y. We'd probably want the X and Y to be half a tile over. So I'm trying to think of what the best thing to do is. I think probably what we'd want to do here is actually start drawing in a little bit how these things are layered. This would be a good thing to have debug info for. And so maybe what I'll do is I'll postpone this until when we actually have the debug code. We might say something like draw tile chunks so we can verify that things are aligned in the chunks we want them to be in, etc. Because that'll be if we had some debug rendering stuff, it'd be really easy to verify what I just said, but since we don't, it's a little bit harder. So I'm just going to go ahead and double check that what I just said is working properly. It is. Looks like that's fine. Now you can see that floor is much higher up than it was before, which is because we changed the floor height to 3 meters, which is exactly what we would expect to happen. And let's see here, when we go upstairs, we also go up at a much faster rate because we've got to go all the way up to that top part there. So there we go, and that all works good. So that seems pretty consistent and reasonable, so that's fine. Okay, so let's leave that at that. So now what we have to do is start to say, all right, how tall should everything be, right? How big should everything be? And let's start to take a look at that. So let's go into Handmade world.cpp here. I'm sorry, handmade.cpp, where we add our entity sizes. And let's just think about this a little bit. If we're going to add an entity, how big should it be? Well, a wall should probably be the tile depth in meters, right? It should be the full height of the floor, is what I would think. And since we don't do inclusion on the max, I feel like even though it goes all the way up to the top, we wouldn't even need to leave an epsilon. It would just work. Now, I'm not sure about that. Let's see. So here I'm going to walk around to test that collision detection there. That all works fine. Go up to the top. Collision detection works there. And it works here. Yeah, so we can actually do it at the full height, and that's fine. So that's all good. No worries there. So that's nice. So let's take a look at what things should be other heights. Let's say that we've got the stairwell. Well, we already did that correctly because we said that that's going to be the depth in meters, which is that height. Now, you know what I'm thinking though? If this were only the depth in meters, we shouldn't be colliding. So did we not use that as the inclusion rule? I'm guessing we didn't use that as the inclusion rule. I don't know if you see what I'm seeing there, but if the stairwell is only that big, then why are we able to walk down it? Maybe we can't walk down it. Let's find out. Let's take a look here. So when we do inclusion, when we were doing our inclusion testing, which is this stuff here, when we did rectangles intersect, what exactly does that call do, right? Let's take a look, handmade math.h. Let's take a look at rectangles intersect. So yeah, so you can see what's happening here, right? Basically, rectangles intersect, which is our call for doing intersection testing here, doesn't obey that max rule, which is kind of janky, right? That's not probably what we wanted it to do. That's just not, like, all of our testing is basically predicated on the fact that, you know, if I've got a rectangle and let's say, oops, here's my min corner, here's my max corner, right? All of it was predicated on the fact that that very last row or column, that very last infinitely thin edge is not included in the rectangle. And the reason that we're going with a rule like that is so that you can stack two rectangles perfectly together, right? Like let's say I got a second rectangle here, like so, and you know definitively what the people at this coordinate are on. You know that they're on this guy, right? Not this guy. If the max were included, then there'd be no way to perfectly stack two rectangles next to each other without trying to figure out what the minimum floating point epsilon value was at that scale that you could use to put you one floating point unit over from the other guy, which would be a huge pain and definitely not something we want to do. But for our rectangle intersection testing, we're not doing that, right? Our rectangle intersection testing says that you have to be less than in order to be considered intersecting. I'm sorry, in order to be considered not intersecting, which means that anything that was on, if the two rectangles abut in any way, then they are considered, they're considered intersecting, which I don't think we want to do. So even though that happens to help us in this particular case, because it means that when I walk up this thing, I can walk down it again, because I happen to be exactly on it, both at the bottom level and the top level, what I think that we would rather do is fix that by having stairwells hit regions extend above the floor a bit, which I think we want to do anyway, right? I think that's something that we would want to do anyway, but I don't know. So anyway, we could take a look at that, and that's something that we should play around with a little bit, just so we can kind of see what's going on there. Now that said, I don't actually know that's what's saving us. It could be that I'm not quite thinking about this right, because like what I'm also noticing is that if I walk into this guy, it stops me. And I feel like it shouldn't actually stop me, because I feel like our collision, that should not actually have been the case. Let me think about that a little bit. But if you know what I mean, right? It should be that if you try to walk into it, the thing that would have stopped it was this test wall call, right? Because we're not stopping you down here in the overlap testing. So it seems to me like we're actually still intersecting the stairwell even so. So that's actually not the thing that's stopping us, but it doesn't change the fact that it's wrong. And so first I want to fix that, and then we'll take a look and see what to do with the other part of it. So what we're doing here is we're basically doing an inversion test. So what we're doing is we're saying, let's test first to see whether they're not intersecting, and then we'll just return the opposite of that, right? So to test whether two things are not intersecting, what we want to do here is we're saying, okay, if the min of this thing, right, is less than the maximum of the other one. So let me draw out what this is actually doing. We talked about this before. In fact, I don't know. Can I actually find the drawing? Probably not. That's one thing we don't really have, is how to search our drawings effectively. Because like, what do you do? How can you see where we may have drawn that? Who has any idea? Well, does anyone see it? I don't really see it on here. Well, maybe overlap test at least 1 Here we go. This was the drawing, right? So basically what we were saying before is, we have A min-max and we have B min-max. And so what we're doing is we're checking for things like, okay, if the minimum of B is greater than the maximum of A, then we know that they can't be overlapping, right? Because there's space in between where this one ends and where this one begins. So what we want to say is, let's suppose the max and the minimum were exactly equivalent, right? So B's minimum was right on the maximum, right? In that case, we would not consider them intersecting. So what we actually want to do is we want to change these tests here, for example. So when we do min versus max, like the one I just said, so if B's min is greater than A's max, what we want to do is set that actually to be if it's greater than or equal to, right? Because if it's greater than or equal to, we want to consider them not intersecting, because that max is not included, right? And so that's true of all of those dimensions. And so now the question is, what about the other side of that? What about where we're testing the max against the min? And so what we're saying here in this case is we're looking for if B's max was over here, right? And so what about the case where they're exactly coincident again? Again, we don't want that to be the case. We don't want to include that max-min overlap So I believe what we want to do here is, again, say the same thing. We want to say that B's max, if it's less than or equal to A's min, right, that it's not going to trigger the intersection. So that seems to me to be more in keeping with the rule that we set up and avoids us from getting into a situation where we have different tests returning different things. Now, we still are working properly in terms of going up and down, which again, I think is a little odd. So I'm just wondering what I'm forgetting, because in theory now, if we were right on the top, when we go here, we shouldn't actually, we shouldn't be actually going through like that. That's not correct. So my question is, what's actually happening there? And I don't know. So let's try and figure out what is actually happening there. So first off, let's make sure we know how big this thing actually is. So if I go in here and I take a look at the stairwell, where are we placing it, right? So here's the first thing that I guess is affecting it, right? Is we're actually placing these at an offset in the world, right? And oh, well, you know what? That explains it right there. These placements are placing us, so basically what our dimensions are interpreted as being around where we are, right? So basically when we say what the dimension is, I guess I got to zoom back to where we were. No, let's see here. Day 76. Where is day 76? There it is. This is such a funny drawing at this point. All right, so here's day 76 again. There we go. Am I the right size? It's hard. That's the other thing that I don't know how to get this to do, is to zoom to a known size. I really wish Mischief could just do that. I don't know, maybe it can, and I don't know how to do it, but yeah, it would be nice. So does this look about right? I think that looks about right. I think that's how big things were. So let's just say that that's how big they were and keep going. So I guess what's happening here is just that our entities are actually this size, right? Our entities, not size, are actually placed like so. If this is the ground, right, then essentially our entities are doing that. And so that explains why they can go and they're considered intersecting these stairwells that are, even if the stairwell is only set up to be that way. So what we want to actually do is place entities such that they're, a base and their dimension kind of goes up from the base like that. So I wonder, I'm just thinking how we want to do this. I wonder if that implies that our rule for where entities are should actually be that the position, you go out from the position, but you go up in Z. I don't know. You know what I'm saying? Like in terms of how you align the bounding box of the entity, I wonder if we want to make it so that your alignment is, from for the standpoint of a three-dimensional drawing here, right? I wonder if we want to make it so that essentially the point is in the exact middle of the bottom face of your bounds, and so the height is measured that way, whereas the other dimensions are not. The other dimensions are measured, as being equally spread out from where you are. I mean, the other thing we could do is that everything is a minimum corner. So you're always specifying your minimum corner, and then everything is out from there. I don't know. I don't know how I feel about that. So let's take a look at where it's actually used, for starters. That'll give us a little bit of an understanding of it, I suppose. So if we were to go into sim region and take a look at basically the places where I actually do something with it, well, so here's an example right here. And then we've got another example. Let's see. So we actually... So we do a fair bit of stuff that wants to be symmetric, like entities overlapping rectangles and sizing them. So it really looks like we want to just keep treating it that way. So it seems like what we want to do is we want to do that placement where we're going to place things so that they're adjusted properly. Yeah, I feel like the center plus the dimension is just a better thing to do there. Yeah. So, I mean, that's what it is. That's what it is. So I guess what we want to do here is say, all right, let's go ahead and just account for that. Maybe what I'll do is make a call in addition to add low entity, something that takes a dimension. I'm not sure. Let's take a look here. Add low entity. Everything has one. So maybe I'll just add that to the call. And it will automatically maybe do that adjustment for you, let's say. Yeah. So I guess what I'm going to do here, and I guess we should give the sword a dimension in Z as well. Maybe just a very small dimension in Z. I guess what we should probably do here is say, all right, let's add a new function, and there's going to be a function here that basically does the same thing as add low entity, but it's going to be let's say a grounded entity, right? And a grounded entity is going to have, a dimension and a position, and we'll say that when you pass in whatever that position is, we're going to offset it. We're going to go ahead and offset that position by whatever the dimension is. So when you pass that dim in, you won't have to set that anymore. It'll kind of do that for you. And so what this will do is it'll call add low entity with the position and the type that you specified. And then it'll go ahead, and set the dimension for you as well. But it'll also do, before it does that, it'll do that mapping for you, where essentially it offsets wherever the entity was. So if I take a look at handmade world.h, oops, there should be that offset for call. Where is that offset? Map into chunk space, so this, right? So if I do that map into chunk space, world position, offset P, and so what we'll do is we'll say we're going to map into chunk space the original P that we got, and then we'll take the dimension, we'll say that we're gonna offset it by half the dimension in Z downward, so to sort of, upward, right? So that we'll move it up to account for that, so that it will be based on the ground properly, but that its actual placement in the world will leave its bottom, the bottom of its bounding box on the ground. All right, so we'll go ahead and return that, and that looks good. So we've got now some work to do here, where I'll basically say the dimension is going to be, let's see, something like this and this. So there's a wall, and then I can say add grounded entity dim and delete that, right? Does that make sense? None of the overloads. Of course you would make me do this. Thank you, C. Oh, right. Maybe it wasn't as bad as I thought. Let me give it another chance. Okay, now. C was not being mean to me there. It was just me forgetting to select the Z coordinate. All right, so, and I guess I have to pass the world there too, probably, right, to this guy. So, oops. So it knows how to do that mapping. So that should allow us now to place things. Let's double check that that actually worked at all. That should allow us to place things properly in Z, and we'll see if it actually did. And of course, our guy is now lower than the walls, right? So he's like down a bit in Z. And so now that should stop happening once we actually place him properly as well. So let's go ahead. We've got add wall, we've got our add stair. So if we want our dimension again, let's go ahead and set that up. So we've got, there's the X, we've got our Y here, pass that in there, and our Z. So pass that in there, and that will automatically do its thing. So add grounded entity, entity. There we go. So now what we would do is we would just get rid of this, so we don't actually need that offset anymore because it should just offset itself. There we go. And what else we got? We got our S word. Our S word isn't a problem because it doesn't actually have a position at the moment, so we can leave that B for now. Our player, he should be grounded, so let's take his dimension here and actually set him up properly. And he should be about 1.4 meters high, right? That was what we said the height of the hero should be, I think. No, that can't be right. He's not 1.4 meters. He's a little kid. We did this before, but I forget what it was. How tall is, let's say, a velociraptor? How is that the most common? What is going on here? All right, well, whatever. How tall is, I don't know, maybe he's, let's say, I don't know how old he is. Let's say 7-year-old. 63 centimeters, right? So 0.63 meters. Does that make sense? Right? You know what I'm saying? 0.63 meters is how big our kid will be. There we go. Seems reasonable. Yeah, that's just how tall he is. So if I go ahead and move these out, we've got he's 1 by 0.5 by 0.63f. Delete that. And we'll add him as grounded. And we will add his dimension there. And that looks about it. Oh, we're almost out of time. So let me just finish this guy up for the Monstar. The Monstar is 1.0, 0.5, 0.5 at the minute. I don't know why our Monstar is so much taller than our guy. But I guess that's just because monsters are bigger and scarier. So we'll add grounded entity there. Dimension. And again, dim equals 0.5, 1.0f, 0.5f, 0.5f. Oh, that's good. Dot x. Well, good that we caught that accidentally. There's the familiar. And we'll have to do some more work on the familiar later because we actually want the familiar to float, and we haven't done anything about that yet. So, add grounded entity. There we go. So what's the problem here? No semicolon. Nobody likes the missing semicolon. So let's go ahead and run that and see where we're at. Let's see if we can actually stop our guy. That looks a bit wrong to me. It looks like we're still lower than the trees are, which isn't my intention. So I've got a little bit of bogusness happening in my code. More importantly, we're still getting that, so that's a little bit odd as well. So something's a little odd. Let's just take a couple more seconds to take a look at that. Where is my add grounded entity code? There it is. So let's see. Let me just make sure I did this reasonably. So map into chunk space. We're taking the initial P, and then we're doing that mapping. We're adding it at the offset P, so that seems right. We're saving the dimension. That looks roughly correct. Let me go ahead and step into that, but otherwise I guess we'll have to leave it here tomorrow, and we'll debug it tomorrow. Grounded entity. Let's see what it says here. So map into chunk space. Oh, you know what though? Now that I think about it though, really our drawing code is slightly wrong. In fact, I should fix the drawing code first before I look at this. our drawing code uses the Z placement to determine where to draw the guy, but it really should use the minimum of the Z bounds, right? It shouldn't be using this as the entity Z, right? Instead, it should be using, it should actually be using that point offset by, it should be using that base point. Because we're drawing up from the base point, that's how we were actually doing all of the other rendering, right? Like when we draw the rectangles, we're actually doing, I assume we're actually doing that, but I don't actually know if that's true. How are we doing it? Let's see. Draw rectangle, player left top plus 9 entity width height, 1.0. Let's see here. Player left top, player left top. Where is player left top? Okay, there it is. So player left top, oh, we're not using that code at all. That code is just bogus. Entity ground point, entity Z. So when we do this computation, when do we actually offset the point by entity Z? Right there. So what we're doing is we're saying that the center is the offset. Yeah, you know what? This is going to take a little bit because this I think is just wrong. I think our drawing code is just bogus to begin with. So that is actually, it's not a fair test to say that it would look like it was in the wrong place because this code is just kind of bogus. So what we should probably do is fix this so that it's actually drawing it so that the Z is actually starting at the lowest point and going up from there, because that's actually how we're thinking about the drawing in terms of how far it should be offset. So that does seem a little bit bogus, which is how we're doing it. But either way, we've got some bugs to deal with. So I'll leave that for tomorrow. I'll put that on the top of the to-do list. So we already went through and went how tall things are. So let's say debug drawing of Z levels and inclusion of Z to make sure that there are no bugs, because there are some now. Okay. All right, so let's go ahead and go to the Q&A. If you could please fix your question with Q:, so that I can see it. And try to keep it to things that we've done on today's stream or on a previous stream. If you want to ask off-topic questions or things about what we're going to do in the future or any other thing like that, please do it in the pre-stream. Come about 15 minutes before our scheduled stream start time, and we do off-topic questions then. We didn't do any today because we wanted to give everyone the opportunity to watch John's programming lecture, so that's why there wasn't one today. But on days when John isn't doing compiler demos, we always do pre-stream questions. So that's the time to answer those. Or sorry, to ask those. That kid you just created is around 2 foot tall. Yeah, isn't that, does that not seem right? That's right. Is there anything wrong with that? Oh, you think that basically that thing that we got was just bogus? So people are saying that that's too short for a 7-year-old. So better data is at growth chart boys girls height weight at halls.md. Wait, so just curious, what is the actual height for a 7-year-old in that case? Has somebody looked it up? So as for, someone asked, I was wondering, why do you have 2 windows open and not just one? The answer is because I find that it's most effective to work in a manner where I can have 2 files open at once. Typically, so I can do things like, you know, if I'm working on simregion.cpp, I often want to see simregion.h at the same time. So I just have hotkeys to allow me to view those. And then I break my files up such that I can see like my data types all together that make sense of things that I want to look at together. and then so that I have my CPP files, when I'm working on them, I can quickly see a bunch of the types that are involved in that CPP file. Over 4 feet seems right for a 7-year-old. Okay, well, I wonder if we can find, here we go. Let's see. Male children, 7, height in inches is 48. So, oops, 48 inches in meters. 1.2. Oh, so we were actually pretty close before. That's, all right. So let's go ahead and update that. Add player. That's what it's called. So he's about that tall. Let's say. Let's see. Any other questions about stuff that we were doing? Doesn't look like it. Looks like mostly non-programming related questions. As for the apps that we were using for the dev environment, yes, it is. GNU Emacs is the editor. Dev Studio is the debugger. And we use this Mischief app for drawing, but that's not really a development tool. It's just what we use for illustrating things on the screen. If you wanted to, you could get by with just Dev Studio because it's got editing built in as well. I don't like its editor very much, so I don't use it, but there's nothing wrong with that. People do it. People definitely follow Handmade Hero using just the Visual Studio editor. I think there's some trickiness in doing some of the live code editing stuff that we do. Getting that to work properly with its build is a little janky sometimes, but you know I'm pretty sure people have worked it out by now how to do that properly in Visual Studio. So you don't really need the Emacs part of it. That's just the editor that I prefer, but you could do it just with basically everything that we're doing. You could do just with Visual Studio, which is free. You can use the Community Edition, which Microsoft makes available for free. Let's see. Any recommendations for tracking down heap corruption bugs? So what I typically do for heap corruption bugs is let me see if I have any other questions that are like on topic to stuff we've been working on, because it's a good question, but it's not really related to what we're doing at the moment. Let's see. Yeah, so, well, let me just answer this question, because it's a good question. So typically, here's what I do to debug heap corruption errors. So, you know we've got this memory arena thing, right? And the way that the memory arena thing works is I go ahead and I just allocate out of a memory block, right? And so every time we do an allocation, we don't actually allocate any memory, really. We just increment an integer. So I mean, our allocator, it's still an allocation, right? But our allocation is boiled down to just like plus equals the size. That's the entire work of the allocation. And that's intentional because I want allocation to be completely free. Like I don't want any time spent, games should spend no time allocating and deallocating memory. If your game spends any time whatsoever allocating and deallocating memory, in my opinion, that is a poor architecture because there's no reason for it, it's not necessary, and so all you're doing is wasting CPU time that could be better spent computing something else or doing something that would make the game better rather than allocating or deallocating memory, which is not making the game better, it's just bookkeeping. So that's the way I tend to do it, and that's intentional. But what that means is it's very, very difficult to track down heap errors in this case because anytime you overwrite some of the memory that you may have allocated here, right, you will never know. You'll just corrupt some other values that are, you know, somewhere else were being used for something else, and you'll get a bug, but it's a hard to find bug. So typically what I do, and we haven't had a reason to do this because we haven't had any corruption bugs in the program so far. Typically what I do when I debug something like that is this class, this sort of, shouldn't really say class, this tool, this whatever you want to call it. I know I say class, in my head sometimes I think of things as classes, and they're not what everyone else thinks of as classes, so I try to avoid using that term so that people won't think about virtual functions and stuff like that, because that's not what I mean. I kind of mean this utility, this thing that does stuff, right? So basically this combination, this initialize and push, so these two functions here, what I'll do is I'll extend them to basically have two versions. One version that I use for actually shipping the game, which looks pretty much exactly like what you see here, modulo a few things that we'll probably add later as well. But then the other version I have is a debug version, which what it does is instead of actually doing the allocation in this nice clean way that I've set up here, it actually does do an allocation every time you do a push. And what it does is it calls through to the OS layer and asks for a block of memory with a special debug allocation routine. And what that debug allocation routine is it does a virtual alloc or a mem map, depending on which platform you're on, right? But it does one of these. And the way that it works is it asks for the memory. If you imagine the allocation, right? Let's say that this is the virtual page size. So let's say that this is a 4K page, right? Because that's how big page boundaries are in regular page size operation. They can go up to 64K and 2 megabytes and other things like that. But let's say that the page size was 4K for now. So normally what happens is when you do a virtual alloc, right, you allocate some memory and you start using it right from here, right from the first byte offset of the page, and you just use however much you're going to use. And you know, there's these 4K pages, they're mapped into your process space and everything's fine and whatever. But what that means is that if I was to do a virtual alloc and ask for the amount of memory that I actually wanted, let's say I wanted 6K, right, I would get back this region here, and it would map these two pages for me, and I could write stuff into here, and it would just write into here, right? And if I wrote over this, nothing would happen until I actually wrote off to here. Like I'd have to write past the end of the page here, right, if I did a virtual alloc. And maybe this would actually be mapped for all I know, so it might be that nothing would even happen then. I just get silent bugs because, you know, this thing's overwriting its bounds. If I were to overwrite this way, I'd be more likely to fault. But again, even that could be mapped. And usually people very rarely underflow buffers. Usually you overflow buffers. That just tends to be the way things go. So what I do is I virtual alloc basically a bigger range than I need. What I do is I allocate an additional page, right? So that basically I've got you know, something that looks, you know, that's too big to even draw. So let's do this way. Let's draw the pages a little bit smaller. There we go. So 4K, 4K, 4K. What I'll do is I'll allocate it such that I place, I allocate one extra page than I need. So 6K needs 8K worth, you know, 2 pages to fit. I'll allocate actually 3 pages, so one more than the amount I need. And then I'll essentially align the 6K the other way, so that the 6K boundary starts here and ends here, right? It ends right on the page boundary. What I then do is I take this extra page that I've allocated and I mem protect it. I do virtual protect on that page, and I set it to not be allowed to be accessed, read or write. What that allows me to do is even if anybody ever in the code ever overwrites by even 1 byte the end of the buffer, you get an immediate page fault. And that is a really easy way to track down memory errors. What you can do is you could run your program twice in 2 different modes too. You can do it this way, and then you can do the same thing but do it in reverse. Line up the page so that you mem protect the first page, and you align it like that. So now that 1 byte overrun in the other direction will fault. And if you run the program once with this allocation scheme and once with this allocation scheme, you will have guaranteed that you will have hard faulted on any type of overrun by 1 byte in any direction. Now, this gets a little more complicated if you have alignment issues. So if you are aligning your allocations to, say, 16-byte boundaries, which is common in SIMD operation, if you're doing that, then you can't ever really do anything about the fact that you're going to be always 16-byte aligned, which means that someone could overwrite a boundary by up to 15 bytes if the allocation wasn't actually allocating the full amount. But since it's unusual to allocate less than a 16-byte granularity for a 16-byte aligned thing, usually this isn't a problem. But that's typically what I do, and then I run the program once in this way and once in that way, and that should get you just about everything. Hope that makes some sense. Let's see. If you're not allocating memory as the game goes, are you allocating a bunch at the start? How does that work? Yes, we allocate all the memory at the outset. At the moment, we allocate a lot more than we probably actually need because we're just in development right now, but later we'll probably have a little bit more to say about exactly how much we should do. But if you want more information about that, obviously you can come here to the video archive, and if you look at the video archive, we've got every single day of codings on here. You can go look up exactly what that was. So I believe, let's take a look here. Platform independent game memory is probably the one to look at. The start, but I'm not entirely sure. I think that's probably it. So I would probably take a look at that and just, you know, watch the video. It should tell you. What are the Linux equivalents to these functions? I think mmap and mprotect are the Linux equivalents to the functions. So let's see. Do we have any on-topic questions? Still no. So I guess I'll try to do the closest. I'll try to sort questions by the closest to on-topic. Does that seem fair? Let's see. How far along are we in developing the game? We only do an hour a night, and so the number of days is the number of hours, roughly. So we're 76 hours in, which is like, we're almost on day 80. That'll mean we're at our 2nd week of programming, if it was a work week, right? 40 hours a week of programming is the typical amount I kind of figure. So we're about 2 weeks in, and so we don't really have an engine yet. We're working towards the engine. So basically we are, we're at the point where we're getting pretty close to having all the stuff spec'd out that we actually want in our engine. We've got a little to-do list here that is stuff that we want to still sort of figure out. Mostly, this is the kind of, this first part here is mostly the tricky part, and I guess a little bit down here, which is this stuff. But yeah, so we've got, I'd say we've got at least 2 full weeks of programming more to do to get through a lot of these things and kind of have a better sense of it. And then once we're done with that, we'll start on game production proper, and that's like writing the real renderer and then kind of like working through all of those systems and making sure they're all like full quality and stuff like that. But yeah, so we're not very far into it, I would say. I mean, 2 weeks is not very long to be programming on a game, especially when you're programming from scratch. So, you know, I would expect, you know, you wouldn't. It's pretty unlikely to make any kind of game from scratch in that kind of time, if you're you know, not using an engine or something like that. Oh, and someone was suggesting munmap is another Linux equivalent call. Is this in C++? Yes. Well, it's sort of C++. We do use a little bit of C++ things. So if you look here, you can see in our math library, this stuff is C++, right? Operator overloading. We also use some function overloading, and that's mostly it. We also, and we use the fact that we don't have to use type defs to define struct names and union names, stuff like that. But that's mostly it. So really, we're sort of programming in C, but technically it is C++ because we use a few C++ features here and there that we, or I should say that I, think are useful. I stay away from most of the other C++ features that I don't think are so useful. Does C++ compiler generate hidden code like constructors, copy constructors, etc. in the way that you structuring the game? So I'm not really sure how to answer that question. I mean, every compiler, like even a straight C, generates hidden code, right? Like if you were to assign a struct to another struct, that does essentially like a memcopy, right? And you didn't write that code, and so you're not controlling how that stuff got copied. And similarly, like, you know, in terms of various ways that things could be happening, yeah, I mean, there's stuff that happens that's hidden code in that sense. Like C is not one-to-one readable in a way that like directly implies what the assembly language is doing modulo, you know, assignment of registers or something. So in some sense, I would say that hidden code is getting done, yes. But in another sense, I would say most of the time we're staying away from any like weird hidden code generation. We don't use templates, we don't use constructors and destructors, we don't use stuff that's going to proliferate a lot of code that we don't explicitly write. We do use operator overloading, so that's some hidden code, and that's for vector use. And so pretty much, if that's what you mean by hidden code, I would say operator overloading is the primary place for our vector operators. That's the place that you would see the compiler generating code that's not obviously there when you look at it. Do you use the STL at all in your code? No, I do not. I don't think the STL is very good, and I wouldn't recommend using it. It's the things that are provided in the STL are very rudimentary and simple. They are not complicated pieces of code, and they are done in the STL in a way that's very complicated, cumbersome, and I find problematic when used in real code bases, and so I would never recommend using the STL. If you need something like that, you should write it yourself. I think it's well worth the effort to make sure that you don't rely on it, because it's not well designed and it's not well executed in general as a piece of software. So, and in general, you want to try to avoid having your basic operations like data types like that being done in something that's, you know, kind of janky. Okay, I think we maybe are coming to the end. Coming to the end here. Let's see. Yeah. Looks good. Looks good. I'd say that's pretty much all for today in terms of questions. So I am going to Yeah, I am going to go ahead and call it. I don't see any more questions. So I'm going to go ahead and close things down here. We know what we're doing tomorrow, so that's good. Yeah, so let's go ahead and end for the night. Thank you very much, everyone, for joining me for another another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to get your own copy of the source code, you can always pre-order the game on handmadehero.org, and it comes with the source code. I upload every night after I'm done programming, so that you can play around with it at home if you want and use it as a thing that for learning and stuff. You can kind of tweak things, and that's a good way to learn. I find is to be able to play with stuff, break stuff, and kind of just figure out how it's working in a more hands-on way. So if you want to do that, you can do that at handmadehero.org with the little pre-order button. If you want to support the video series, we also have a Patreon page. If you go to the Patreon page, you can subscribe there, and that's a way to support the video series, and it's always very much appreciated. We also have a tweet bot, so you can follow the series. We're here every weeknight. Basically, sometimes we're in the mornings on Fridays, for example, so we will move the times around. So if you want to know the schedule, you can always click on the tweet bot, or you can, if you are on Twitter, you can follow the tweet bot, and that way you'll get the tweets delivered to you. And it tweets about twice a day, once in the morning to say when the stream will be, and once an hour before the stream starts. It also has a weekend thing it does where it tweets out the schedule for the whole week, so you can always take a look at it that way. So that's kind of handy too. Got a video archive on YouTube with all the old videos, and we also have a news and forum site which also has an annotated version of the video archive, which is pretty awesome. I highly recommend checking it out. It's also got some great coding resources up there, like ports to Linux and Mac if you're trying to follow along on a platform that's not Windows. It's got a place where you can ask questions. It's just got lots of good stuff. So if you're trying to learn from the series, I really recommend checking it out. Some people in the community have done some really helpful things up there, and it's just a good place to go. So again, thanks everyone for joining me. Tomorrow we'll be back here at 8 p.m. Pacific Standard Time, our normal slot. We were 30 minutes late today because we moved the stream up to give John's stream a chance to finish. We always try to move the stream to accommodate the compiler demos that John does, because I'm pretty excited about the language he's working on, and I want everyone to watch it and be excited about it, because I know I am. So that's why we were 30 minutes. That's why our scheduled time was 30 minutes. It was 8:30 tonight, but tomorrow it'll be back at 8 p.m. And it should be 8 p.m. for the rest of the week until Friday, when it'll be at its 9 a.m. slot as usual. So pretty much other than today, every day is it's a normal schedule for this week. So I hope to see you back here tomorrow night. Have a wonderful Tuesday. And yeah, enjoy coding till I see you again. Take it easy, everyone.